I'm Tsvi with Aqua Security, and we're going to spend the next 25 minutes or so talking about the implications of running your applications in multiple modes in the cloud and how to do security for them. So what we want to do is we want to achieve a platform for multi-modal security that can cut across containers, functions, and cloud services. The idea is that we want to have all these synchronized so that wherever we want a workload, we can be sure that its security is always going to be consistent according to what our needs are. But let's take a little bit of a step back and understand what really brought us to here, right? We have applications that have been re-architected to a set of microservices, and those microservices are generally broken apart inside of the application. And what we're seeing now is that over the past 3.5, 4 years, we are also breaking them outside of the monolithic application. We're actually distributing them along a wide range of cloud platforms or even internal data center platforms. And all of these are becoming cloud native workloads. And those workloads are going to carry the functions of the application that used to be in one monolithic program that was run usually on a single computer or on multiple computers just running the same applications. So what is really those cloud native workloads? They can be containers, right? We talk about containers all the time, but it can also be functions, serverless functions that carry maybe short-lived tasks that somebody needs to do in response to maybe a request. We're still running servers, but if we run them in a cloud native way, those servers are not managed like you would a server. Nobody actually now deploys a server from scratch, installs the operating system, and then slowly ramps up the software on it until they get what they want, right? These are servers that may need to be there as servers for high capacity, but they're not really managed as servers that are managed on an ongoing basis. A lot of it is done with orchestration. So Kubernetes is becoming the operating system for all these cloud workloads. You can manage things in Kubernetes like containers, but you can even expand that to manage other things. And the cloud providers are doing a lot of work to make sure that they can expose a lot of their backend infrastructure and compute and storage and all that as Kubernetes resources. And then each cloud has their own thing that they're known for, right? If you want Alexa, you have to go to AWS. If you want analytics, you might want to go to Google. So all these cloud services and the databases and the storage and all the stuff that comes inside of the clouds are also something that is considered part of that cloud native workload because it's part of the overall applications. Now, regardless what all these things are, we have to agree that they have certain properties that are pretty common. One is that they almost always come from pre-stage artifacts. Again, nobody deploys a server and then slowly builds the software on it. Because of that, once they're running, they're also immutable. So you usually will not want to add any pieces of software or do even patching in those workloads when they are running. And they're small, so they perform a single business function. So a container that needs to do, let's say, authentication services, you're going to put all the stuff that you need in order to do that inside of the container, run it, and if you need to change it, you need to output a new image. So you update those workloads by replacing them, usually with a new version of the image or the template that you're using to deploy them. That means that the atomic unit of deployment, that server or that pod in Kubernetes is throwaway, right? We really kind of don't care about the well-being of a single workload. All we care about is the deployment as a whole. We need the herd to be healthy, but we really don't really care about the specific of each individual workload in that herd, and we are able to then replace them if we need to as we change them or as they have problems. And then all of that requires a lot of automation. That's another thing, because we are not going to control, hundreds of workloads over the same infrastructure by manually going and looking into each one of them. So automation is key. And this is really kind of a novel thing, right? We really haven't done that on a large scale for quite a while. So there are a couple of disruptions that happen. One is that the cloud itself is a disruption. So shared infrastructure, shared responsibility, getting stuff out of our data center, boundaries of ownerships are blurred. The security controls, sometimes they're cloud specific, sometimes they're not. The DevOps practice itself is another disruption, right? We increase the speed of automation, right? You could commit something into a Git repository and then automation can deploy it in a new container, sometimes within a matter of minutes or even seconds. All these toolings don't really have an established security practice, and that's kind of the fault of security organizations and the security industry as a whole for not keeping up. But we got to understand that that governance still needs to be there, and it needs to be reshuffled and needs to be distributed so that we can achieve the same result that we want for security only on these new deployment models. So how do we actually secure that, right? If security is disrupted, if those prepackaged artifacts are under the purview of development or the people that design the applications, and they will control what operating system, what backend services we need, what are the programming language that we're going to use. Again, it can ship in seconds based on a trigger. And usually, if you run it in the cloud, you might not have your traditional controls like perimeter controls or network, even host controls if you're running functions that you would rely on in order to understand what's going on and make sure that the security is appropriate to the type of workload or the application that you're running. So security is disrupted. We have a lot of novel things coming into the way that applications are designed. And what we really need is a new approach. We need to confront the fact that things are really not going to be the same way going forward if we're going to start to make heavy and heavier use of these application modes. So the idea of defense in depth, right, where we had a perimeter and we slowly work our way to the data, is not something that we can accomplish. We probably could never accomplish it in the cloud anymore, but even with newer workloads, we really can't do that because all these workloads are portable. What we do need is a new approach that is going to find the commonality between all these types of workloads and applications, and we can now control them without being specific on which environment we control them. And that's because everything that we're going to deploy has an artifact. So it comes from an image, there's some code in there. You really can't run software without code. That software is not going to do anything unless you put it on some kind of infrastructure, because we still need servers. Even in serverless, we still need servers. And once we marry those artifacts with infrastructure, we get a workload, which is the live thing that we want to protect and we want to preserve. So however you look at it, in a cloud environment, in a cloud native environment, even if it's on premise, you will always have an artifact that needs to be deployed on some kind of infrastructure, and that generates some kind of workload. And this is generic enough that it can actually be used in multiple environments. And later on, we're going to see how we can actually apply those things. So the idea is that if we can secure those artifacts, from the supply chain, making sure that whatever we produce is going to be as clean as possible, if we can secure the infrastructure, if we can harden it, if we can provide a safe place for all these good artifacts that have lower risk, that have low vulnerabilities, that are not going to do anything bad, and they need to run, we can then produce workloads that we can preserve and we can protect because the application itself is known. We know where it's coming from, we know what infrastructure it's at, and we're able to protect it. Now, that said, this is all general, right? We need to go down to the specifics and start to understand how we actually apply our security controls in those new environments. So it's going to be the same security. We still need to do all the things that we need to do in security, but it's going to take a little bit of a different form. So what used to be known as firewalling, basically putting big routing devices and gateways and things that scrutinize the traffic into a big data center and segmenting those is not going to work anymore, because that segmentation is very much dependent on the topology of the network. And we really can't do that anymore because workloads can instantiate anywhere. So we need to move to what we call micro-segmentation and grouping and logical grouping so that we can put workloads in groups, we can put workloads in buckets that are protected, but they're not dependent on the topology of the network. It needs to be independent. So doing firewalling without topology of the network, that's going to be the tricky part, but there definitely are ways to do this. Another thing is patching. Patch cycles, the practice of going into servers and auditing them and fixing them and so on, that is probably not going to be with us very long because all these things are coming from templates and images. So instead of doing patching on live environments, we're going to have to move to do patching on templates, image governance, making sure that whatever we produce and push down the pipeline is going to be something that is free of those vulnerabilities and the risk that we want to avoid when we are deploying those applications. If you talk about intrusion prevention, for instance, so intrusion prevention is about identifying situations where the software is not doing what it's supposed to do, where maybe a new process is instantiated or an attacker has commandeered your infrastructure in order to do something else. Well, that's really easy, because if those workloads are truly immutable, if nothing really needs to run in a particular container or a function or even a VM that wasn't designed into it by its image, then we can, first of all, easily distinguish between things that are part of the application or not part of the application. And it's also very easy to provide the security controls that will prevent those things from running. Privileged identities, specifically for humans, is something that we might need to do less and less of in these kinds of environments because of automation. And that's actually a very, very good thing, because that automation is going to reduce human access. It's going to reduce the mistakes that humans do. On the other hand, we have to have governance over the automation scripts themselves and good access to the automation environment, right? If we're going to run anything from a CI, our CI platform now becomes a single point of intrusion. So that's something to think about. We need to move our privileged identities from downstream on the servers upstream into the CI and the automation that's driving this whole thing. Same thing with anomaly detections. A lot of times security products had problems identifying really what belongs to the application, what doesn't belong to the application. We've seen on patching cycles and immutability that we have a lot of information about the components of the application and what it's supposed to do from earlier in the design, because we're going to encounter it a little bit earlier based on the image or the template, and we have the application context. So we can actually be a little bit more efficient and maybe not ask too many questions before we do an incident response. And that incident response is really what is going to, I think, make the biggest change. And that is that because these workloads are managed as cattle and the individual workload really doesn't matter as much, you can quickly isolate, preserve any data, and then scale back up. And that is a really sea change for security, because a lot of times we know what to do, but we're afraid to do it because we don't want to create disruptions in the application. So by cloud native workloads being more resilient, we should be able to do a lot more. So the only way to do that, again, because we're talking about large scale workloads, because we're talking about things that move in the pipeline, security needs to jump on the automation bandwagon. And that means that security policies need to be written as code. You can't really just have a PDF or an HTML that somebody can read and know what to do with security. Security needs to provide those rules as code. Put acceptance gates in the deployment process. So whenever you make an image, you should be able to quickly assess if it's going to be appropriate or not for this environment. Have some mandatory execution of those policies along the pipeline so that you have the ability to reject images that are not part of your approved path. And then those remediation and response cycle really need to take advantage of the automation so that response, for instance, can be executed via Kubernetes. And we really don't need a lot of overhead with security-owned services that are going to do that response. We can use the cloud response, the Kubernetes response as part of what we do. So all of that together, right? We have a new way to deploy applications. We have a finite set of security controls that we need to execute. How does that really look overall? And the way that it looks overall could be a little bit scary, right? We have a big table here. We have, on the left-hand side, a lot of the things that we need to do as security, take care of the application code, the artifacts, the workload, the cloud, nodes and servers, segmentation, process, user, incident response. There's probably a lot more that we can add to that list. And then we have all the different ways in which applications can now become applications. You can have a virtual machine in the cloud. You can manage your own containers. You can use cloud managed containers with Kubernetes. You can use serverless functions, or you can use some of those cloud services. So how we fill in this matrix is going to have a lot of impact on the security of our applications overall. And let's just go down the list, right? If we need to secure our code, and we have some KPIs that are going to indicate whether or not we're doing a good job. So if you're writing your application code, your own custom code, scanning it for code weaknesses, static analysis, dynamic analysis of the code is going to be applicable throughout, because the idea is that we can take this code and then put it on top of a container, on top of a function, and then make sure that, that it's going to behave the same way and it's not going to have those vulnerabilities. The cloud services are not going to expose their code, so we have less of a way to impact. However, we're going to see that we can impact the cloud services in other ways, just not in the code. Another thing that is important to understand is that the artifacts that we're deploying, right? We're taking our code and then putting it on an image operating system as a base image or on a VM image. Those artifacts also need to be understood. What is the risk of them? What is the supply chain of them? How did we get them? What are those base images? Where did they come from? All of these things need to be transparent so that we can provide a good analysis of the risk in that complete artifact. And we really shouldn't forget that workload configuration, specifically in Kubernetes, specifically in environments that have a lot of automation. Those things that you can do with a Kubernetes deployment file, like assign higher privilege, volume access, things that determine really how that container inside the pod will eventually going to behave, those are important. And of course, if you're working in a cloud environment, you can embed both containers and serverless functions with some permissions to cloud resources. So what IAM role in Amazon, for instance, you're running with, what is the application role that you're running in Azure and so on. So those are things that we really need to understand. So all of these together, these are all code, right? The application code is code. The deployable artifact is code. The workload configuration is also code, because a lot of time it's kept in a code repository. This is also part of the infrastructure as code. So all of these need to be assessed, and we need to understand what is the level of risk before we allow them to move down the pipeline to configure the infrastructure or deploy the applications. Speaking of the infrastructure, we can see that everything eventually needs to run on some compute resource and also have access to storage and other things. So cloud configuration is really, really important. What is the virtual cloud circuit? What is the network that something is connected to? What is the configuration of Kubernetes itself? What is the version of Kubernetes itself if it's provided by the cloud provider, right? You may not have the ability to go into the Kubernetes API server and tweak things, but you can definitely select the latest version of Kubernetes the cloud provider is giving you, because that is usually going to be more secure and it's going to have more features and capabilities. Same thing with serverless functions. You have the choice of the runtime engine, right? So if you have the ability to select a higher level of your Python, Java, Node type of implementations, you should be able to gain more and more security. And of course, on the cloud services themselves, there's going to be best practice per service. A lot of times those are versioned as well. So you can have RDS with Postgres version 9, 10, 11, 12. Again, the more you choose that's appropriate for your software, the more security you're going to get. And then if you do own some of the nodes and the servers, especially on the VM side, then you need to follow those hardening guidelines. Those are not going to be provided by the cloud provider, because they are not going to be assuming responsibility for this. So the idea is that we're going to have to take care of our own servers. Anything else is really just making sure that automation is what's driving it, and not human access, because we need to minimize that human access. We need to minimize the number of people that have access, let's say, to your cloud console. We need to make sure that everything is audited, everything has two-factor authentication. So all of that is really about making sure that we're not leaving any cracks by which an attacker masquerading as a human or even somebody who's not trusted in your environment can do some damage in your cloud infrastructure. So if we produce clean artifacts and we put them on infrastructure that is good, then we have those workloads. And what we worry about with workloads are really kind of two things: how they communicate, and then what happens inside of them. We used to really think about the placement of a workload as what is going to inherit its ability to communicate, right? The old firewall methodology of I have my segmentation already there, and where I put things is going to inherit where that segmentation is. We need to kind of think about it in a little bit of a different way, because those workloads can really instantiate anywhere, and we can't really rely on the fact that there is going to be that firewalling where they instantiate, especially if you're creating clusters on the fly. So that minimal required connectivity really needs to be driven by the properties of the workload themselves. And then we kind of paint them in a color that makes sense for their environment. And then you can easily understand if they are open to the world, if there is accessible resources, and make sure that all the connectivity that you have in a particular workload is designed only to serve the application and really not anything else, especially now that we really don't need to provide external connectivity like SSH access to a running container and so on. With process, resources, user, really everything that happens inside of a workload, there is quite a bit of control on the virtual machine side. So sources, the resources that are used by the application, we need to understand if they're really needed or not. We have a way maybe to trim down the payload that we have in those VMs. But when we're talking about containers, that preventing of drift between the container and the image that it came from is really what's going to secure it. Because if an attacker really wants to put their own piece of software in your container or their own foreign container in your Kubernetes environment, we need to understand what we're expecting. And we have that because that's part of the security that we get in the earlier stages of the pipeline. So if we have a particular application that just needs to run HTTPD, we can guarantee that it's not going to run anything else because there's really no need for it to run anything else. With functions, the same thing. Access to the underlying operating system, functions are a lot more condensed, but still there is an operating system underneath it, and we make sure that the function does not have access to it. And then cloud services, again, you're not going to see the cloud provider giving you the ability to go into the specifics of how their backend processes work, but controlling the cloud identity around that is going to be extremely important because what you assign to a particular user or a particular technical user or a service account inside of Kubernetes is going to have implication in the cloud environment. So this is really how we can control users, is by controlling the permissions that we give them in the cloud. So to kind of summarize what we very, very quickly talked about, when we talk about artifacts, right, we want to make sure that we can control the software sourcing and composition over the entire supply chain. It means that if you're getting a package from GitHub, you really got to know what it's doing. We've had instances where there has been repo poisoning and packages in GitHub were pretending to do something, but they ended up doing something completely different. We need to build those images with the minimal components that we need in order to run the workload. So no bloated images, not a lot of operating system commands in the application. And then harden the image file system as much as we can, like permissions on the files, the number of users that we have, high user ID in Linux. All of those things are really going to contribute. And the reason why we're mentioning it is because those are now controlled by developers. So it's no longer that ops is going to determine what is the user ID that application is running on. The people that design the applications, the people that assemble the applications, they're going to design that user ID that sits inside of the image, and security needs to understand that and approach them and make sure that they understand what the guidelines are. On the infrastructure side, again, harden anything that we can according to the best practices for that particular service or asset. Use the tools provided by the cloud providers. They usually know how to best configure their own stuff. And then we need to continuously verify that configuration. Even if we are using a lot of automation and we really don't expect people to come and mess the settings that we had, there's always the chance that somebody would do that. So we need to continuously verify that configuration. And that goes to the hardening of NOS all the way to the IAM permission in AWS. And in the middle, we need to make sure that our Kubernetes environment is set up correctly and nobody changed, let's say, the permissions on etcd or added a service account in Kubernetes that we didn't expect. And on the workloads themselves, we need to classify those workloads via labels, annotations, kind of break apart that connection between a workload and its infrastructure so that we can define the segmentation with logical attributes, and we can keep those workloads immutable and prevent administrative access to them. So once we've established that a workload can run in the environment, it really doesn't need to change anymore. And the only thing that should change is the rollout of a new image or the rollout of a new container. So a summary of the summary is these are all three, right? We need to take care of our artifacts, we need to take care of our infrastructure, and we need to take care of our workloads. And if you remember just one thing, one slide out of this entire presentation, is that this one. If we can clean our artifacts before deploying, make sure that we reduce as much risk as we can. If you can reduce the human contact with the infrastructure, and if you give those workloads just enough privilege in order to work and nothing else, we will have better security overall, and it's going to be consistent because this thing is not specific to VMs in Amazon's or containers in Kubernetes. This is really general guidelines that whatever type of workload we have, it can fall into these three buckets. And as long as its artifact is clean, as long as its infrastructure is secure, as long as the workload itself is configured properly, we should be able to control the security. So I appreciate your time on this session. I hope you have a great rest of your day, and thank you very much.